All right, this is where it actually gets really interesting and a little bit wacky. So we just showed that if you had a solution to SAT, you could use it to solve three-colorability. And maybe that's not so weird because three-colorability is about finding some kind of a satisfying coloring. And so we have a satisfying formula. It's all not so weird. Now what we're going to do is the other direction. To show that three-colorability is NP hard, we know it's in NP, but is it NP hard? If it's NP hard, it must be NP complete because it's in NP. But to show that it's NP hard, that means we have to take some NP hard problem and solve it by way of three-colorability. So that means we have to be able to take a satisfiability formula, somehow express it as a graph coloring problem. And if we can do that, that means a solution to the graph coloring problem will solve satisfiability and therefore anything in NP. Now we're going to take a little bit of a shortcut just so we can get to the punchline fast. And we're only going to deal not with the full satisfiability problem, which gives any kind of Boolean formula, but specifically 3-SAT. 3-SAT are just the satisfiability formulas that have the form like so, where the whole formula is a bunch of ands of clauses. So it's a clause and, clause and, clause and so on until all the clauses have been expressed. Each clause itself is the or of three literals, and a literal itself is either a variable or the negation of a variable, not v. So you could have something that looks like x or not y or z and w or x or not z, and that's a 3-SAT problem. It's not a very hard 3-SAT problem, but it's a 3-SAT problem. And of clauses, each clause has three literals. Each literal is either the name of a variable or not the name of a variable. Now, it just so happens that this problem is also NP hard. It's NP complete, just like satisfiability, but it's a lot easier to work with. So if somebody walks up to us and says, well, I have a general satisfiability question, it might be easier if they just walked up to us and said, I have a 3-SAT question. Now, this is not easier in the computational complexity sense. It's just easier in the just working with it and writing an algorithm sense. But the problem itself is equally hard.